Hi, we'll be starting in a couple of minutes. Hi, Ganesh. Welcome. Hi. In the meanwhile, get started. Right. So, can you guys introduce yourself? Ganesh, can you hear me?
Hi, sir.
Hi.
Can you hear me?
Yeah, I can hear you. Yeah.
Yes, yes,
Cool. And you can hear me loud and clear, right?
yes, yes, sir. Yes, yes, yes.
Cool. Perfect. And Lenovo, I'm not sure. I think that's the name of the laptop, I guess. So, can you introduce your name?
My name.
The person with who joined us, Lenovo. In the participants list, I see the name Lenovo.
I don't know exactly.
Okay, okay, no problem. No problem. We'll just get started in a couple of minutes.
Okay, sir.
Hi, Vamsi. Welcome. We can't hear you, Vamsi. Maybe there is something wrong at the connection mic aspect. We'll just see if the mic part is working fine. Okay, let's get started.
Yes,
Hello,
sir.
everyone. Yeah, welcome
Hello, sir.
to this particular workshop. So, what we are going to do in the next 1 hour is we are going to look at how exactly a Google data scientist interview goes along, right? And we'll also do a mock interview. Basically, I will be asking you questions based on your responses, right? So I'll be again giving you feedback as to how you can improve that response. Okay. So I want you guys to be engaged. So basically, you can mute yourself till the time I choose your name, right? So in first, what we'll do is we'll just see what a Google data science interview looks like in the first 5-10 minutes, and then I'll start asking questions. Okay. At that time, I'll unmute you and I will ask you questions. Okay. Does it sound good? Okay, so we have Ganesh and Vamsi. we'll be looking at that. Okay, cool. Let's get started. So what exactly are we going to discuss today? So first, we're going to look at what exactly you can expect in a Google data scientist interview, the preparation strategy, what kind of efforts are required to crack the data scientist interview with Google. And then we'll start with the mock interview where I'll be asking you 4 questions, and we'll be looking at the 4 questions kind of at a high level represent the type of questions that you can expect in a Google data scientist interview. Right? And then at the end, we can have general Q&A regarding any of the things that you might have any questions about, right? And we will see how we can proceed with that. Okay, and to a brief introduction about me. So my name is Sai. I'm one of the SMEs involved with AI Quotient. So the main goal here is to help people prepare for machine learning interviews, because that is where a big roadblock is present when it comes to transitioning from completing a course to landing a job. That's where a lot of effort needs to be kept. And based on my experience of interviewing a lot of data scientists, we are looking at preparing a packaged way of helping people understand what are the nuances of data scientist interview and how you can proceed along tracking it. Okay? So this is what you can expect in a Google data scientist interview. So at the crux, at the bottom level, you can see that problem solving. So many of the questions that a data scientist, or for that matter, any person who interviews with Google, he can expect a lot of problems in the interview. It's not going to be a typical tell me about yourself, walk me through your resume kind of questions that you can expect in a typical Google data scientist interview. It's based on our analysis of a majority of candidates who have attended Google data scientist interviews. Right? It's like every time you can expect at least a couple of problems, brain teasers, as you can see, right? Puzzles, mostly around probability and linear algebra, because you're a data scientist preparing for a data scientist job, right? And probability and linear algebra are the foundations for everything that you're going to learn, be it machine learning, deep learning, reinforcement learning, graphical modeling, anything and everything. Right? So that's one thing that you can expect in the Google data scientist interview. And the next thing is scenarios. So they're not going to just give you numbers and ask you to crack that problem. They're also going to imagine yourself in those scenarios where you're going to apply that logic, right? And then see how you can use that to solve a real world problem. Right? And the best way for you to prepare for this would be to go through a variety of case studies, variety of projects, AI projects, where you can pretty much pick a problem from scratch, that you are not working on those typical Titanic data set, Iris data set kind of problems. Those kind of problems everybody works on. Right? So this is where we are talking about you taking real world data, right? Like let us say World Health Organization statistics, right? With the recent coronavirus that's going on. Right? What kind of analysis did you do? And you just have data when you don't have any guidance from anyone. Right? So that's exactly where your decision making ability is going to be tested. And that's exactly the kind of questions that Google puts you through in round 2, round 3 of the interviews. And then coming to the final rounds, right? So when you are actually getting closer to moving to the next round, the final rounds, right? There, they expect you to not only know the basics of machine learning, the basics of deep learning, they also expect you to know entire end-to-end pipeline of deploying a machine learning model. Here you are looking at a full stack data scientist, right from getting data, analyzing data, building a machine learning model, iterating on top of it, fine-tuning it, deploying it, monitoring it, and also figuring out when exactly the model needs to be replaced. End-to-end machine learning pipeline. That's exactly what you're going to expect in a Google data scientist interview. Okay, now that you know what to expect, how to prepare for it. Right? So the preparation strategy, I kind of divide it into 4 parts. If you look at it, you need to get your fundamentals right first. Right? You need to be pretty much sure about probability, linear algebra, the basics of it. We're not talking about advanced concepts in both these categories, because most of the interviews that we have seen, right, they touch upon the most popular concepts of probability, which we're going to see today. Right? The odds ratio, probability values, right? Probability distributions. Those are the kind of common concepts that they get really deep into. Right? And then you also need to focus on portfolio. So because you're preparing for Google, right, if you want to impress the recruiter for your resume to get shortlisted, see if you can do projects that align with Google strategies. Right? Say, for example, if you look at Google strategy when it comes to machine learning, most of the products that they've built rely on recommendations. Right? So build a recommendation engine. Right? Be it, it can be a retail recommendation engine, it can be just a content recommendation engine. Right? So build a recommendation engine. So that is one way to get your resume recommended, right? Or build a job recommendation engine, build any recommendation engine. That is one way to stand out in your resumes, right? And then the other thing would be look at other Google products like Google Maps, self-driving cars, right? Object detection, object segmentation. So pick a problem which aligns with Google strategy. Google kind of pretty much tries to build everything and anything, right? That solves a problem. And there are so many problems to be solved, right? So that's the reason why if you can build products that match with Google strategy, right? So some projects that can match with Google strategy, the chances of your resume getting shortlisted would be higher, right? And then comes the operationalization part. Here, you are no longer supposed to be just working on, as we discussed earlier, just building a simple model, right? Here, you are going to be accountable for everything, starting from getting the raw data, cleaning the data, analyzing the data, building a model, deploying it, everything, end-to-end machine learning pipeline. Because that is one thing they do test among the data scientists. Because at Google, you are supposed to be the one who gets to take calls, right? Make big decisions when it comes to what kind of data do you need and what kind of analysis that has to be performed, right, to actually solve the real world problem. And finally, you need to have really good communication skills because everybody is a techie, right? And you need to, the only way you can show your strength of a particular concept is when you can explain that in a simple manner, right? So that even a 10-year-old or 15-year-old can understand. Right? So you need to keep, because generally people, because it's Google, they go overboard with technical jargon in interviews, right? But you don't do that mistake. You try to keep things simple because the simpler you explain a concept, the more command you have over that concept. Right? So that's another dimension that you need to add to your preparation in order to finally crack the Google data scientist. Okay, awesome. So with that in mind, let us try some mock interviews because I can go on with multiple slides explaining all these things, but that doesn't really distill the whole concept of preparation. Let us actually prepare for the interview by taking some questions. Right. The first question would be for Vamsi. Is that fine? Vamsi, can you hear us? Can you hear me? I can't hear you. Okay, I can actually see you typing, but I can't hear your voice. Okay, so let us see what the first question is, and then we'll see how we can figure it. The first question is: you are at a casino and have two dices to play. You win $10 every time you roll a 3 or a 5, and you lose $3 every other time. Let us say someone invited you to a game where you will roll the dice 18 times. Will you participate in this game or not? This is one of those popular puzzles that Google comes up with, right? When it comes to them trying to understand how much you can use probability in real world to make real world decisions. Right? That's exactly what this problem is. And if you see, the scenario is simple. You are throwing two dice, right? Whenever you get a total of 3, whenever you get a total of 5, you win $10. Right? The other person is going to give you $10. Right? And whenever you don't get these summation to be 3 or 5, right? Every other scenario, you will lose $3. Right? Now, the other person has invited you to participate in 18 games. Right? Now, what you need to do is you need to pretty much predict in advance whether what are the chances of you making a profit, what are the chances of you making a loss. If you think you will incur a loss, then you'll not be entering, isn't it? You'll not be playing this game. Right? So how will you decide on it? That's the question. Think about it. Think of it. basics of probability is all you need to tackle this question. What you are looking at is something called expected payout. Let us see how that payout pans out. First, let us see what are all the scenarios. Right? When you throw two dice, these are all the scenarios, right? You'll be seeing 36 different combinations. So here 1, 1 means the first dice show 1, second dice also shows a 1. Right? 1, 2 means the first dice show 1, second dice show 2. Right? Like that, you see all these different combinations for this dice. Right? Now, look at all these combinations. How many combinations correspond to 3 or 5? Because those are the combinations that you're going to win. How many combinations here correspond to a 3 or a 5? If you observe closely, these are the combinations, isn't it? The combinations which are marked with a cross, those are the combinations that correspond to a sum of 3 or 5. 1, 2, 1, 4, 2, 1, 2, 3, 3, 2, and 4, 1. No more combinations, right? These are all the combinations. These are the only times when you actually win a game, right? And now that you have a reward of $10 for winning a game, the probability of you hitting these combinations is nothing but 6 by 36. Denominator has all possible combinations, 36. Numerator has 6 because there are only 6 combinations that correspond to the rule, the logic, right, at which you win the game. Right? So 6 by 36, which is nothing but 1 by 6. So 1 by 6 is the probability that you actually win a game, right, under these rules. That means out of 6 games, you will be winning 1 game. Out of 18 games, how many games you will be winning? 3 games. At the max, you can win 3 games by applying the logic of probability. Now, the same logic, if you apply to losing a game, 5 by 6, right? There are 30 combinations, right, using which you can lose the game. So 30 by 36, which is nothing but 5 by 6. 5 by 6 into 18, which means the rest of the 15 games you'll be losing. So 3 games you'll be winning, 15 games you'll be losing, and every time you lose a game, you have to pay how many dollars? $3. That means the total expected payout, expected reward, is nothing but 3 times the win, the money that you get, 3 into $10, which is $30, minus 15 into $3 every time you lose, which is nothing but 30 minus 45, which is nothing but minus $15. That means you're always going to lose minus 15. That's the most likely outcome. And sure, there might be chances that every time you get lucky, every time you get either a 3 or 5, but that is extreme case. This is more of a normal scenario. On an average, you're going to lose $15 if you participate in this game. That's the reason why you should never, ever play this game. Somebody tells, okay, these are the conditions, right? You should not get excited by the fact that you win, you get $10, and you lose, you just spend $3. The chances of you winning are significantly less here compared to chances of you losing. So that's the reason why you should never, ever play this game. Okay? Good. Now let us look at the next question. The second question, if you look at it, how do you build a data scientist job recommendation engine? So this is one of the questions that is fairly popular, right, when it comes to Google's interviews, because as I told you, Google is a huge fan of recommendation engines. They've been building recommendation engines ever since 1990s. Right? Now, what they're asking you is, can you build a job recommendation engine that kind of is better than others out there? Right? How do you answer this question? Okay, so think about it. How exactly do you build a data scientist job recommendation engine? Right? So here they're not looking at you giving them the perfect answer. They're not asking you to build the best job recommendation engine out there in a matter of minutes in front of the interviewer. Here they're more like trying to understand your ability to think end to end, the entire machine learning pipeline that we're talking about, right? So that's exactly what we're going to see. So you start with the basics, which is nothing but defining the problem, collecting the data. Collect job postings from websites like Indeed.com, which is indeed a popular website for data scientist job openings. And then once that you collected the data, you focus on cleaning it, because job postings inherently is a lot of text, unstructured data. So you need to apply a variety of NLP techniques where you need to apply the entire natural language pipeline, natural language processing, to completely clean the data and convert it into a format which is consumable, either by a deep learning network or a machine learning, right? And then you explore the data and understand the factors that define the job candidate fit. Here, what we mean by this is, what do you think are some of the factors that lead to the ideal candidate getting matched with the ideal job? Look at the data. Look at what are all the job postings, right? Who ultimately, how many people, how many candidates applied to this? When was this closed, right? So, and maybe you can also do secondary research, trying to understand who among your network got the job of their choice through Indeed.com. Let's see what are all the requirements, what are all the matches that happen between the keywords that are mentioned in the job and the resume of the person who ultimately got shortlisted. Again, it's not going to be straightforward. You need to actually collect data through surveys, right? Or you need to directly go and ask people about the match, right? Or you can reach out to companies and then try to ask them as to how exactly was the job candidate fit based on job description and resume, right? As Vamshi rightly said, requirements and skills of the candidate, right? And then the next step is you build a model. It can be an unsupervised learning model like K-means clustering, right, where you can figure out what are the different types of jobs which are closely related based on keywords. You can pretty much calculate cosine similarity to figure out which of these jobs sound similar, which of these jobs are more or less the same, right? And that way you can see what are all the jobs that are perfectly matching to a particular candidate. The candidate has a variety of attributes, job has a variety of attributes. You do a cosine similarity of these two vectors, and you will see whichever job has the highest match with the candidate's capabilities, right? You recommend that job to the candidate. Right? It's a plain old vector transformation. That's what we'll be doing, and we can use that as one of the machine learning algorithms. That K means cosine similarity, latent factors, right? You can use all those techniques, and then you can evaluate the model. So pick up a metric that you think that is going to perfectly objectify the thinking that you are doing when it comes to building this, thinking it through and deploying it in application. Right? So once you evaluate the model, make sure that you do the beta testing with some of your friends, family members, or for that matter yourself, and then see if the recommendations are making sense or not. And then finally deploy the model, build a front-end application, deploy the model, right? And then monitor the model, see how the model drift is happening, right? And then you repeat the process, because it's going to be iterative process. It's not going to be one stop all, a one-time effort. It's going to be continuous effort, because we are talking about building a job recommendation engine for data scientists, which I believe currently in the market, you kind of get lost in the noise. There's just too many postings out there and too many people applying for the postings. And sometimes the worst part is you don't know whether your profile matches that requirement or not, right? And that's the reason why a lot of time is spent, a lot of time is wasted in you going after some opportunities which are better served not going after, right? So that's exactly where the broad job candidate match you can come up with this job recommendation. So this is kind of holistic, systematic approach that Google is expecting, and they ask questions like open-ended questions like this. Right? So what is a how do you build a job recommendation? Okay. Now comes the third question. The third question that we are going to cover is this. This is probably one of the most popular questions that have been asked in Google data scientist interviews. The question is this: how can you tell if a given coin is biased or not? So by biased coin, what we are looking at is the coins used by lead actors in movies like Sholay and Dark Knight, right, where the coin is heads both ways. Right? We are trying to look out that somebody has a coin, and we need to predict whether that coin is a biased coin or whether it is a unbiased coin. And that guy is going to do whatever you say, but he's not going to tell you upfront whether it's biased or unbiased. You need to figure out whether that coin is a biased or unbiased coin, right? And how exactly you're going to do that. So that's exactly what Google is asking. How? How can we do that? How can we actually come up with an approach that will tell us whether the coin that the other person has is a biased coin or an unbiased coin? which concept, which machine learning concept, which probability concept are they looking at in this particular question? It is the popular hypothesis testing concept that they're looking at. What is hypothesis testing? Initially, you start with the hypothesis. Let us say you formulate the null hypothesis that the coin is not biased. Coin is a fair coin, right? That means you are saying that probability of heads is equal to 0.5. Right? That is what you are saying. That is your null hypothesis. Now, let us say you ask the other person to conduct an experiment. You tell the other person, flip the coin 7 times and tell me how many times you got heads. So that guy is going to flip the coin 7 times, right? And he says he got 7 heads. All 7 times he got heads. Right? Then you calculate the p-value. What is p-value? If you see the left-hand table, right? What is the probability of somebody getting 7 heads when he throws the coin 7 times? The denominator again, probability is nothing but 2 power n, 2 power 7. And in the numerator, how many occurrences are possible? Only one possible occurrence, isn't it? All the time, right? It is going to be a head. Right? It says 1 by 2 to the power of 7, which means 1 by 128, which is something around about 0.01. Right? And you can look at the table for all the other cases also. That means there is only a 1% chance. That means if you throw a coin 100 times, right, there is only a 1% chance that you will see all heads, all the throws resulting in heads. When you're throwing the coins 7 times, 100. Right? When you throw the coin 7 times and you conduct this experiment 100 times, there is only 1% chance that all 7 times you will end up seeing heads. Right? So that's exactly what second step is. You flip the coin 7 times, you found the p-value. Now compare the p-value against the alpha value, which is exactly what we take into consideration when it comes to accepting a null hypothesis or rejecting the null hypothesis. Why did you take alpha value 0.025? Generally it is 0.05, 5%. That's the threshold. Why did I take 0.025 here? Because we are looking at a two-tailed test. Here, what is the null hypothesis? Probability of heads equal to 0.5, which means our altered hypothesis is probability of heads not equal to 0.5. Right? Less than 0.5, greater than 0.5. Because it's a two-tailed test, it can fall, the real event, it can fall in either of these tails. Right? This is going to be a two-tailed test, and that's the way we are going to compare the probability value with 0.025. And is 0.01 greater than 0.025? Nope. Right? If p-value is greater than alpha, then we can accept the null hypothesis, which is the coin is a unbiased coin. Right? Because the p-value is less than alpha, we can conclude in this scenario that the null hypothesis is wrong. That means the coin is biased. We are talking about a Cholet coin. We're talking about a dark knight coin here. Right? So that's exactly how, in this particular question, Google is trying to see how you can apply the concept of hypothesis testing, which is a complicated concept. Not many people understand it or get it first time. And that's the way they're looking at how you can use this concept, explain it in a simple way, so that you can solve a problem like this in real world. Right? Testing whether a coin is biased or not. Whenever these kind of problems come in, you should automatically get into the mode of hypothesis testing. Right? Now the final question for today's discussion. The final question is this. Vamshi, can you hear me? Am I audible? Audible? Okay, cool. I'm just trying to see if your voice is audible or not. Okay. Unfortunately, your voice is not audible. Otherwise, I could have asked you to answer these questions. I'm unable to do that because your voice is not audible. So that's why I'm asking the question and I'm also telling the answer. Okay, no problems. I think what we'll be doing is, so this is the last question anyway. So what we'll be doing is we'll be anyway conducting more workshops going forward. At that time, you can give it a shot. Okay, cool. The final question for today is this: convince your grandma that regularization is important for improving a machine learning model. Why exactly do we use regularization? Regularization is another concept that for many data scientists, it's like an optional one. Right? You learn about linear regression, you learn about Bayesian trees, Loess regression. Regularization is more of an afterthought. Right? Only the experienced data scientists actually understand the importance of regularization. Now, here the question is Google is taking it to the next level. Right? Convince your grandma that you are going to tell your grandma who has no knowledge about machine learning, mathematics, algorithms, all that stuff. You're going to tell her in simple terms the importance of regularization. And that's exactly what this question is looking at. And how do we do that? Now you think about it. What kind of arguments, analogies you're going to bring to the table to make sure that your grandma understands regularization. Right? So if you look at it, let us take a simple example. Let us take put grandma herself at the center of the story. Let us say you are going to a fun fair, okay, and go back to your childhood. And your grandma said, you enjoy the rides at fun fair under two conditions. Ensure that the ticket spending is not more than 30 rupees. That means you go and spend, enjoy the time at fun fair. But the ticket spending should not be more than 30 rupees. Right? And the second condition is you return home within an hour. Okay, so that is what he has mentioned. Now, you decided to honor the first instruction. What is the first instruction? You should spend only within 30 rupees. Now, how will you proceed in that under that condition? Let us say this is the only condition. You don't worry about second condition. Let us say this is the only condition that you're looking at. How will you behave under this condition? You will know that money is more important than time because you're just focused on money here. That means what you will do, you will first observe all the rights from a distance, and then you will take only those rights that you believe you can enjoy. It is like typically cost conscious behavior. In the real world also, whenever money is very important and time, you have all the time in the world, you can spend insane amount of time in a shopping mall trying to figure out which shirt you need to buy. Right? Because time is there, money is important here. Right? So you have all the time in the world. So what you'll be doing, you are prepared to spend an extra 2 hours in the shopping mall just to get 100 rupees discount. Right? So that's the kind of typical behavior that you are looking at under this particular condition. And that's the reason why what you'll be doing is you will be first looking at all the rights from distance, and you will not even touch some rights. You will selectively choose only a subset of rights. And you will not even touch all the rights. Right? And that's exactly what lasso L1 regularization corresponds to. Right? What lasso does, lasso, as the name suggests, it just cuts off things. Right? It essentially sets coefficients to 0. It will not even consider certain variables. What's the whole point of regularization? It is to improve the generalization ability. It is to prevent the machine learning model from getting overfitted. Right? So that's exactly what you are doing here. You are making sure that those variables that add noise to the machine learning model, you are going to eliminate them. Right? And you are going to keep only those useful variables, just like how the kids behave under the money constraint. Right? And that constraint you add here in the form of this last term that you see, the magnitude of all the coefficients. Right? That's exactly what you add the cost function. Right? So this is you explaining to a grandma. Now your grandma understands, right? So L1 regulation is nothing but I being fast finicky. Right? Now let us see the second type of instruction. Right? Let's assume there were 10 rights. Okay, here second instruction is what? Here time is not a constraint now. Go to the second instruction. Right? Here time is a constraint. Money is not a constraint. You return home within an hour. You only have 60 minutes. Now time is more important. Time is of the essence. Right? So that's what you do. You first try to complete all the 10 rights. How many rights are there? You just try to take all the rights because now money is not a constraint. Right? Let us say each right takes 3 minutes. In first 30 minutes itself, you complete all the rights. You sampled all the rights. You're no longer watching from distance, right? And then taking a decision. you are actually getting involved and taking a ride and then taking a decision. Right? In 30 minutes, you complete all the rides. Now we have 30 more minutes. Right? Now what you will do, out of those 10 rides, whichever rides you enjoyed the most, you are going to take only those rides. Again, multiple times. Right? That's exactly what ridge regression means. Here, you are not going to completely cut off some coefficients. All the coefficients are going to be considered. It is just that you are going to give appropriate importance to all these coefficients. So this way, there will never be that regret that maybe I ignored an important variable. Right? Here, you are going to consider all the variables, but you are going to give weightages appropriately in such a way that the most important variables have higher coefficients, whereas the least important variables have lesser coefficients. Right? So that's exactly what you are looking at. Right? So this is how you can explain regularization to a grandma. Try this with your grandmas and then see if the explanation sticks or not. Right? To summarize, honoring instruction 1 is nothing but where money is important, time is less important. That is exactly where lasso regularization comes in, where you will just cut out some variables altogether from the model. Whereas in the case of ridge regression, here time is of the essence, money is not important, in which case you will sample all the variables, you'll give importance to all the variables, but then you'll be adjusting weights in such a way that the most important variables have the most important. Right? So to summarize, this is how Google's data scientist interview happens. Right? You first need to know what to expect in a data scientist interview. As I told you, you need to prepare. Right? Make sure that you are very good with probability, statistics, foundations, right? Because that's where most of the brain teasers problems come from, the Google data scientist interview. Then you need to practice, just like in today's scenario, right? You need to put yourself in those scenarios where you actually take up questions. Right? Take as many mock interviews as possible. Most of the time we feel that we know concepts, we think we understand all these concepts, right? But only when you try to explain to somebody, that's when you see the gaps in your understanding, right? And the more times you put yourself in those situations, the better you would be performing in the actual interview scenario. So take this opportunity as part of AI quotients, mock interview workshops, right? Put yourself in those scenarios, and that's how you get better in it, right? And because cracking Google data science interview is not probably one of the hardest tasks in the data scientist world, right? And then always try to keep things simple, right? When you're presenting, make sure that you are never talking about jargon. Today we saw how we were trying to remove as much jargon as possible. Right? We're trying to keep things simple. Again, these things can be kept even more simple. Right? That's how you improve your understanding or your explanation of concepts. Right? So that's exactly what Google also expects. So in the interviews, keep things simple and persist. Right? So it's not easy due to the competition. You are never going to. I mean, most of the people uh, have to had to give 5 or 6 attempts before landing the dream job as a data scientist at Google. Right? So do persist, be it preparation, be it just like how you persist when the data is not clean, when the machine learning model is not giving you the right results. Right? The same thing you'll also be doing when it comes to cracking this Google data scientist. Right? With that, we come to the conclusion of the workshop. Any questions, Vamsi? Any questions that you want to discuss? Unfortunately, your audio didn't work. Right? But if you have any questions, you can just post them in the chat window. Okay. I see that you don't have any questions. Cool. Right. Hope you enjoyed this session. So we'll be looking at more of these workshops in the coming weeks. Right. If you have any feedback to share, do drop an email at support@aquestion.app and we'll be helping you out with queries. Thanks a lot for joining the session. Have a great rest of the evening.